Where in the coordinate plane do the equations, line equations 2/3 x minus 7 and 5x plus 2y equals 5 intersect? So it could be pretty tempting to kind of draw this out, and if you are fast at that sort of thing, by all means do it. I find that I end up spending way more time than I want to whenever I have to draw a coordinate plane that looks pretty good and is going to be able to deal with slopes of 2/3 or something like that. It's not that I can't do it, it's just that I'm not as good at doing it fast. So whenever there's another way, I go with another way. This one, you totally should go another way. So the point where these two intersect, they will intersect at the same xy coordinate. That is the definition of the intersection. So the point at which these two lines are equal is going to be the point that they intersect. So we can just set the equations equal. And we can either try to make equation, so we'll call this guy number 1 and this guy number 2. We could either have them, we could either make this guy look more like number 1 and have a fraction in there. I don't really want to deal with fractions. I would rather make number 1 look like number 2. So let's multiply this whole thing times 3. So we get 3y equals 2x minus 21. Now we still, we could either solve for one of these variables and substitute, or when they're, and actually I guess we want to do 2x minus 3y equals 21 to make it look even more like that. Since we have a 2y over here and a 3y over here, when we use the combination method for systems of two equations, we want two of the variables to cancel out. So if we multiply this whole equation times 2, well, not square, times 2, and if we multiply this whole equation times 3, we'll end up with 6y term in each of them, and then we can just add them together, because this will be a negative 6y and this will be a positive 6y. Let's do that math. So this whole thing times 2 equals 4x minus 6y equals 42. This one times 3 would be 15x plus 6y equals 15. Let's add them together, so we'll just put this guy over here. 15x plus 6y equals 15. Add them together. 15 and 4x ends up being 19x. The two y's cancel out, and 42 plus 15 equals 57. So 19x equals 57, therefore x just equals 3. We do still have to figure out what the y value is. We can just plug it into whichever equation is easiest. We may as well use this one that we had here. So if 5x plus 2y equals 5, 5 times 3, that's our value for x here. 5 times 3 plus 2y equals 5. 2y plus 15 equals 5. 2y equals negative 10. And therefore y equals negative 5. Our points then are x equals 3, y equals negative 5, and therefore the two lines intersect at 3, negative 5. Answer choice A.